Hello? Okay, I'm assuming you probably have a worksheet sitting in front of you that is titled something such as Solve the Systems of Equations by Graphing. And you went to YouTube and you found me, and I'm so glad because I'm here to help you. Okay, really fast before we get started, I'm going to tell you about a couple videos I've got linked because there are three ways to solve systems of equations. There's graphing, which we're going to do here. There's also substitution and elimination. Okay, if you need substitution or elimination, I've got a video over there. I've also got one where I do all three in one video and go pretty quickly. Okay, I'm going to be a bit more detailed in this video. Okay, be where you need to be. I hope you're sticking around. Okay, I also have one other linked over there. To do this, you need to be pretty comfortable graphing a line. If you need a refresher, there's also a video over there for that. Okay, well, let's get started. Okay, first, I want to quickly, this is going to be quick, don't worry, talk about what the heck is a system of equations and why do we even care about it. Don't switch to another video. It'll be fast, okay? I just want it to make sense what we're doing, okay? If your teacher gave you this and said, okay, what do X and Y equal? Well, X and Y could equal a lot of different things, right? X and Y could be 7 plus 0, right? It could be 6 plus 1. It could be 5 plus 2. It could be -1 plus 8. Do you see how I could literally go on forever? I really could, okay? So there's literally infinity answers, okay? Here, same thing. I could have 3 minus 0. I could have 4 minus 1. I could have 5 minus 2, okay? I don't need to keep going, right? You see that I could keep going forever. So when they give you a system of equations, they're giving you more than one equation and they want to know what numbers work for both of these, okay? Because there's literally infinity for this one, infinity for this one. They want to know the one that works for both of them, okay? So look at this. These ones are pretty simple, so I can pick out right here, 5 and 2, 5 and 2, right? So x equals 5, y equals 2. Because 5 plus 2 is 7, 5 minus 2 is 3. So this would be my answer to this system of equations is 5, 2. That's what they want. That's what we're doing, okay? So let's go. All right. One other quick note. You told me we're starting. Sorry. One other quick note. This is important. There are three possible types of answers you can get to this. Don't be scared. You got it. Okay? It'll make sense. You can have one solution like that example we just did, where it was an ordered pair. Okay? One solution. You can have no solution because it is possible to have two equations and there's no numbers that will work for both of them, right? So you could have no solution. You could also have infinite solutions, which I'll show you an example of this, okay? We're going to do 3 examples, so you best believe we're going to do one of each. Isn't that nice of me? Okay, so stick around for all 3 because it's important. You'll probably run into all the types, okay? All right, let's go. Okay, so one way to figure this out, because on that other one, it was simple enough we could just figure it out. These ones, ooh, not so much, right? One way to figure it out is by graphing the lines of these equations, okay? You've probably been doing that. Now, when you graph a line of an equation, it is showing you all the possible answers to that equation visually. That's why we graph those lines. It shows you all the answers, okay? So if I graph both of these, it's showing me all the answers to each of them. So where it crosses, that is where it's the same answer for both because they both have that answer. Does that make sense? Okay. All right, so first I just need to graph this. To be able to graph this, I need it in an equation that's easy to graph, which is most likely slope-intercept form. If you need a quick refresher on that, guess what? Am I so nice? You're welcome. Okay, so to get this into slope-intercept form, I just need y by itself. So I'm going to add 3x to both sides. Yes. So I end up with y equals 3x minus 4. Let's go ahead and graph that. Okay, so I'm going to go down 4 because negative 4 is my y-intercept. 3 is my slope, so I'm going to go up 3. 1, 2, 3 over 1. 1, 2, 3 over 1. I can keep going, right? And I can also go the other way. 1, 2, 3 over 1. All right, and this line goes on forever, right? That's why we draw arrows, okay? So that line shows all the possible answers to this equation. Now let's do the other one, okay? I'm going to do a different color. All right, so again, we need to get this so it's friendly to graph, so I need y alone. So I'm going to subtract 1/2 x from both sides. Okay, so I end up with y equals negative 1/2 x plus 3. Now we're in slope-intercept form. So this is my slope. This is my y-intercept. All right, so my y-intercept is 3. I'm going to go up 3. My slope is negative 1/2. So I can go up 1, left 2. And I can also go down 1, right 2. And look at that. We crossed. Isn't that exciting? And wasn't that so much faster than like trying to guess? Because I love math, and if we had to just guess, I would not love math. So there you go. All right, so where they cross, that is my magic number. All right, it is 2, 2. So x equals 2 and y equals 2. You can also, your teacher might want it written as an ordered pair. So just like that. Okay. All right. So if I plug in 2 for x and 2 for y for both of these, they'll both work. Isn't that cool? Okay. That's my answer for that one. Okay, next one. Remember? So this one was one solution. So let's see what this next example is going to be. All right, this is my system of equations here. These two equations. So they want to know what number can I plug in for both of these, x and y, that will work for both of them. Okay, so to graph this, first thing I want to do is get it into slope-intercept form by getting y alone. Guess what? I did it for you. Wasn't that nice of me? All right, so these are just this written to be friendly to graph, okay? So now this is my slope, this is my y-intercept. Guess what? I was nice again, and I already graphed them for you. Okay, what do you notice here? Okay, these ones crossed. These ones haven't crossed, and it's not looking like they're going to, right? These are what we call parallel lines. They're parallel, which means they're never going to cross, okay? So if they never cross, there is no solution to this, okay? There is no two numbers that will work for both of them. There's an infinite amount for this one and an infinite amount for this one, but none of them are the same, okay? Now, something to recognize is parallel lines always have the same slope. So if you see that your lines have the same slope, that's kind of a flag to be like, oh, this one's going to be different, okay? If they have different y-intercepts, same slope, you're going to have no solution, okay? Feeling okay about this? You're feeling awesome about it? Okay, so there's my no solution. Guess what the last one's going to be? Let's see. Okay, so this one we've got these two equations. They want us to solve them, which means find the number that works for x and y in both cases, okay? So I need to get them friendly to graph, so I need to get y by itself. So I'm going to subtract 1/2 x from both sides here. So I end up with y equals negative 1/2 x plus 3, right? And I would go ahead and graph that. Magic. All right. Then I need to get this one friendly to graph. So I'm going to go ahead and write over here just so I have more space. We've got 2x plus 4y equals 12. I want to get y alone because that's slope-intercept form. So I'm going to subtract 2x from both sides. Okay. So over here I'm left with 4y equals negative 2x plus 12. Okay, y is almost alone. I need to get rid of that 4. Those are being multiplied, so I'm going to divide everything by 4. 4 over 4 gives me 1, so I'm just left with 1y, or y, equals negative 2 fourths simplifies down to negative 1/2 x. And then 12 divided by 4 gives me 3. So I've got y equals negative 1/2 x plus 3. Do you notice something? Look, it's the same line. If I go to graph this, it's the same line. So what does that mean? Well, that means we have an infinite amount of solutions. Okay, so if an x and y works here, it's also going to work here. All the numbers along this line, because it's really the same line on top of each other, are going to work. So there is an infinite amount of solutions. Okay, did that make sense? All right, hopefully it made sense. All right, get your homework done. Be excited for substitution and elimination, especially elimination. Maybe you think I'm crazy, but you're going to love it. Okay. Go to bed and have dreams of math that aren't nightmares.